Hello guys, in this video we are starting the last topic of the center of mass, impulse, momentum and collision, and this is the most awaited topic, which is variable mass system. Now this topic seems to be very tough, but it is not in the real case, and it is very simple and it is very analytical, so we can easily understand this topic. We need to understand only simple one basic, which I would tell you in this video. So let us write down the force, which is equal to the rate of change of momentum. We all know this fact, that force is equal to the rate of change of momentum, and also the momentum is equal to m into v. Now till this time we are facing the questions in which only velocity is changing, and therefore due to change in that velocity the momentum of the system is changing and the force is either applied or it is being developed in the system. So if in the case if this mass changes, then momentum will also change, and there would be a force developed due to this change in momentum, dp by dt, which is called as thrust force. So the simple concept which would be useful in these variable mass systems is the concept of thrust force, which is developed due to the change in momentum, and also that momentum is changing due to the change in the mass of the system. So I will use the concept of thrust force in this systems, in these kind of systems. So let us know more about the thrust force. So the thrust force is equal to mu into v relative, where mu is the rate of change of mass of the system, dm by dt, and v relative is the relative velocity of the variable mass with respect to the system when the mass is not the part of the system. I will explain this point of v relative in the question next, in the next question. So if the mass of the system is increasing, then if mass of the system is increasing, then dm by dt is positive, and hence mu is positive. Therefore the force, thrust force and v relative are in same direction. F thrust is in same direction of v relative, and if the mass of the system is decreasing, and therefore dm by dt is negative. Therefore the thrust force in this case would be in opposite direction to v relative. Then thrust force and v relative would be in opposite directions if the mass of the system is decreasing. So this is the complete property of a thrust force. Now I would explain the application of thrust force by an example. So in this example there is a flat car, and that flat car has a starting mass of m0, which is the mass of that car when it was empty. Now a constant horizontal force F is continuously being applied on this car, and a hopper which is spilling some mass on this car at a rate which is equal to mu, and we have to find out the time dependent velocity of this car and the acceleration while the process of loading. So we have to assume the friction to be negligibly small. So in this question, the initial velocity at t is equal to 0 was v is equal to 0 and the mass of the system was equal to m naught. But at some time t, the mass of this car is, let's suppose, m, and m would be equal to m naught plus mu t, because m naught was the mass of the empty flat car and mu t is the additional mass which is being added by the hopper. Now this is the hopper which is spilling the mass on this car, and it is the sand. The force F is continuously acting on this car, and we have to let us suppose that its velocity at this time is v. So first of all, we have to find out the direction of thrust force acting on this system. Now for that, we know that mu, in this case, I'm writing about the direction. So direction of thrust force, direction of thrust force. So we know that mu is positive because mass of the system is increasing. So if mass of the system is increasing, then F relative, F thrust and V relative would be in the same direction. Now what is V relative? So let us find out that this mass, which is not in the contact with the system at this time, is at rest. Its velocity is 0 because in x-axis, obviously, I'm again telling you that this mass is at rest in x-axis at this time, and the system is moving with velocity v in x-axis. So v relative of this mass with respect to system in x-axis would be 0 minus the velocity of the system. So velocity of the system is v I cap. So the v relative is equal to minus v I cap. Now I will again repeat myself that this mass, which is not the part of the system at this time, is at rest in x-axis, and the system is moving with a velocity of v in positive x-axis. So the relative velocity of this mass with respect to system at the time when it is not the part of the system is 0 minus v I cap. So v relative is minus v I cap, and therefore if v relative is minus v I cap, therefore the thrust force F thrust would be equal to plus mu into v relative, and the direction of thrust force and this v relative would be same. Therefore it would be mu into v I cap, in fact with a negative sign. So the thrust force is acting on the system in the negative direction, minus I cap, which is in the backward direction. So this is the thrust force acting on the system, F thrust. Now let us write down the equation of forces for this system, and it would say that F is acting in the forward direction. So net force will be F minus F thrust. That would be equal to ma. Now F is constant and F thrust is mu into v relative is v. Now we have already assumed that the thrust force, we have already calculated that the thrust force is acting on the system in the reverse direction. Therefore again we don't need to take any negative sign in v. So this is equal to m, where m is m naught plus mu t, and a is the acceleration, which is equal to dv by dt. So by rearranging them, I can see that dt upon m naught plus mu t is equal to dv upon f minus mu v. Integrating both the sides, and the limit of the time is 0 to t, and the limit of velocity is 0 to v. So this is the integration of this is ln m naught plus mu t divided by mu, limit is from 0 to t, and the integration of this side will be ln f minus mu v divided by minus mu, limit is from 0 to v. So this is ln m naught plus mu t divided by m naught. This is equal to I'm reversing the limits, so this is equal to ln f upon f minus mu v. So taking anti-log both the sides, this is 1 plus mu t by m naught, and this is equal to f upon f minus mu v. So 1 minus mu v by f is equal to m naught upon m naught plus mu t, and therefore mu v by f is equal to mu t upon m naught plus mu t. I have taken the LCM. You can understand it. So cancelling this mu with mu, v will be equal to ft divided by m naught plus mu t. So this is the time dependent velocity of the system with which this system would be moving at some time t, and the acceleration can be calculated by the formula Fa is equal to dv by dt. So this was the question of variable mass system, and I would be bringing many questions on the variable mass system in the next videos. So keep tuned for the next one. Thank you. In this question, there is a cart which is loaded with some sand of mass m naught initially, and this cart is moving on a horizontal floor where there is no friction, and the constant force of F is acting on this cart. Now initially the velocity of this cart was 0, and due to some hole in the bottom of the cart, the sand is being spilled out through the cart at a constant rate of mu kilogram per second. This is given in the question. So initially at t is equal to 0, the velocity of the cart was 0, and a constant force F was acting on this cart. So we need to find out the velocity of this cart and the acceleration of this cart as a function of time at some time t. So this is also a question which is of variable mass system, because you can see the mass of this system is continuously decreasing. Now let us draw, let us see that, let's suppose this diagram is at some time t. So the mass is continuously being spilled out of this cart, and therefore you can see that at this moment of time the cart is moving with a velocity of v. Therefore the sand which is which has left the contact with the cart at this part will be also moving with velocity v. So relative velocity of this sand with respect to the cart is 0. So this is the first thing, and also we know the formula of thrust force, that it is equal to mu into v relative. But the problem which lies in this part is the fact that v relative is 0. So if v relative is 0, therefore F thrust will be also 0. So the thrust force in this case would be 0. Now if the thrust force is 0, then only single force F would be acting on the system, and at this time let's suppose the mass of the system is m, therefore m will be equal to m naught minus mu into t, where mu is the mass rate at which the mass is being leaving the cart and t is the time. So in time t, mu into t mass would have left the cart, and the remaining mass would be m naught minus mu into t. So writing the equation of Newton's law that F is equal to ma, So F, which is constant force, will be equal to m naught minus mu into t, and acceleration is dv upon dt. Now we can rearrange this equation and we can write that dt upon m naught minus mu into t is equal to dv upon f. So integrating this equation on both the sides, we can see that the limit of time would be from 0 to t and the limit of velocity would be from 0 to v, because initial velocity was 0. So the integration would be ln m naught minus mu into t divided by minus mu, and the limit would be from 0 to t, and here it would be v upon f. So this is v upon f would be equal to minus 1 upon mu ln m naught minus mu t, carrying a limit of 0 to t. So when we will apply the limits, v would be equal to minus f upon mu, and this is ln m naught minus mu t minus ln m naught. You can see that I have applied the limits. So v would be equal to f upon mu into ln m naught upon m naught minus mu t, and this is the equation of velocity for the cart at some time t. And to find out the acceleration, we can easily differentiate this velocity with respect to time, and we would be getting the value of acceleration. So this was the next question of variable mass system. Thank you. In this question, there is a situation in which the sand is being dropped from a stationary hopper on a conveyor belt at a rate of 5 kgs per second. And the conveyor belt is moving with a constant speed of 2 meters per second. So we have to find out the force which is required to move that conveyor belt with constant velocity of 2 meters per second, and also the power delivered by that motor which is producing that force. So we know that the mass of the conveyor belt is continuously increasing due to the sand which is being dropped on that conveyor belt by the hopper, and therefore the thrust force would be acting on that conveyor belt, which would be retarding that conveyor belt. Because if this is the conveyor belt which is moving with some constant velocity like that v, so v is equal to 2 meters per second, and this is the stationary hopper which is spilling out the sand on the conveyor belt. So if the mass of this system is increasing, therefore mu would be positive, and hence the direction of the thrust force and the relative velocity would be same. Now the relative velocity of the sand when it is not in the contact with the conveyor belt with respect to the conveyor belt would be in the negative direction, because at this position the velocity of sand is 0 and the velocity of belt is 2 meters per second. So v relative would be v sand minus v belt. So you can see that v sand is 0, so v relative would be equal to minus of v belt, which is also equal to minus 2. So this is the relative velocity, and this relative velocity is in the backward direction. So the thrust force acting on the conveyor belt, F thrust, would be equal to V relative into mu. And as mu is positive, so the direction of thrust force and relative velocity would be same. So F thrust would be acting in the backward direction, and its magnitude can be, let's suppose this is x-axis and this is y-axis. So I can write that the thrust force would be acting in minus I cap. So it is minus 2 into mu I cap. So this is the direction of thrust force. Now to keep this conveyor belt moving with a constant velocity, the force required by the motor is at least equal to thrust force. Therefore, the minimum force required by this motor should be equal to the thrust force, and therefore I can say that this minimum force required is equal to 2 into mu, where mu is 5 and this is equal to 10 newtons. Okay, now this was the first part. Now in the second part we have to find out the power delivered by the motor. So we know that the power is equal to F dot V, and obviously the motor is applying the force in the direction of velocity of the belt, and hence the force which is produced by this motor is 10 Newton and the velocity of the belt is 2. So this power is 20 watts. Now let's move on the next problem.